Again, welcome to CS 101, Introduction to Computers and Programs Using Python. This is our first lecture, which covers chapter 1 of our course textbook. Our main objective is to understand computer basics. For example, what is a computer, the definitions, and also what is a programs and an operating system. So first we start with what is a computer. Here we say a computer consists of a CPU, memory, hard disk, input and output devices, and communication devices. So from this definition, we can say that a computer is any electronic device that can take an input, be able to process the input, and be able to store the input. So it might have a memory or storage device, and also be able to communicate with other devices. So an example would be our cell phone or a smartphone. A smartphone is a computer because we can input a data into our smartphone, and the smartphone have a special processor which can process the data, can have access to the internet, which means we can have a communications, and also we have a memory to store the data. So any electronic device that have an input and output devices also has a central processing unit and also a storage device and a communication device is a computer. So example is given here as the structure of a computer system. A bus will be the wiring. So a bus is a wire that connects all the devices. So every computer have a storage device, a memory, a CPU, communication device, input devices, and also the output devices. Next, we will go through each of the elements or the components of a computer. So the first is the CPU, which we also call the central processing unit, and is the brain of a computer. Also, it retrieves instructions from memory and execute them. The CPU speed normally is measured in megahertz, which is equal to 1 million pulses per second. And then the speed of a CPU has been proved continuously. Today, we can buy a PC or a computer now, which can have more than 1 gigahertz speed. So again, a CPU will be the main brain of the computer. And normally a CPU consists of different components. The two major components of a CPU will be the logical section, which is the arithmetic logical unit. The arithmetic logical unit perform the arithmetic operations and also the logical operation. Normally, the logical operation will be true, false. Normally, computer understand, you give a computer a question, it give you the correct answer, that true or false. There's no reasoning. Then also we have the control unit. The control unit controls or is the coordinator and controls the flow of data from the memory to the CPU and also from the CPU to the memory. Normally, the CPU also have a special memory, which is called the register. This is where the data that is being processed by the CPU is stored. Next, we talk about the memory. So a memory is a stored data. It's stored data and also a program instruction for the CPU to execute. Normally, when we start our computer, the operating system must be loaded into the memory. When we want to do any work on a computer, for example, I want to use the Microsoft Word to create a resume. When I open the Microsoft Word application or the software, this application must be loaded into the memory. So every work we do in a computer always from the memory. And the memory also is temporary. Data cannot be stored there for permanent. So when the computer power is on, the data will be there. But when the computer goes off, the data will be erased. The data will be deleted. We will lose the data. So normally we have, for example, a permanent storage device such as the hard drive or flash drive, etc. This is where we can store our data for permanent. So here we say a memory unit is an ordered sequence of bytes. Each hold 8 bits. Also, normally the memory also have its specific unit addresses. So it's more like a boxes with its unique address. So a program and its data must be brought to memory before they can be executed. So always execution, we do all our work from the memory. So a memory byte is never empty, but its initial content may be meaningless to your program. The current content of a memory byte is lost whenever new information is placed in it. Next is how data is stored. So a computer system normally understands what we call the machine language, 0 ones and 0 ones. So which we also say a binary numeric system. So data of a various kind, such as numbers, characters, strings, images, videos, are always stored in a computer system as zeros and ones. So that is the only language the computer system understands. So computers use zeros and ones because digital devices have only two stable states, which are referred to 0 and 1 by convention. The programmers, again, need not to be concerned about the coding and decoding of the data. So normally I may use the computer, I may type my name. My name is Charles. I'm using alphabetical CHARLES. To the computer, there's a special program already which have to convert this numeric system to binary numeric system. And we will go through that also as time goes on. How do we convert, for example, a decimal number system to binary? We also have hexadecimal and etc. So the programmers, again, need not to be concerned about the coding and decoding, which is performed automatically by the system based on the coding scheme. So for example, here, if I type a character J in the computer system, it will represent 01001010. It's a 8-bit. So normally in computer system, and one information we call a byte. A byte consists of 8 bits. So that's why if we are going to buy a storage device, for example, a memory or flash drive, the unit always in bytes. For example, 1 gigabyte means we can store 1 billion characters or symbols. And next, the storage device. So as we said earlier, there's a difference between memory and a storage device. A storage device is where we can store data permanent. Example can be a CD, a disk, tape, or Blu-ray, or the hard drive. Data is stored permanent. But with memory, we say it's volatile. Volatile means when the power goes off in your computer, all the data in the memory is lost. So here we say memory is volatile because information is lost when the power is off. Programs and data are permanently stored on storage devices and are moved to memory when the computer actually uses them. So here we have 3 main types of storage device: the disk drives, which can be the hard disk or the floppy disk. Floppy disk now it's no more in market. We have, for example, flash drive, etc. Then we also have the CD drives or the Blu-ray and also tape drives. The next is the Apple devices. So Apple devices will be any device that make it possible to display data on our screen. So a monitor will be an Apple device. Or if we want to print a hard copy report. So this means a printer also is an Apple device. So an Apple device make it possible to print or display information from a computer. So here we say the monitor display information. It can be text and also it can be graphics. The resolution and also the dot pitch determine the quality of the display. In this course, we are not going to discuss about the computer hardware resources. So we are not going to talk much about the dot pitch, the resolution concept, or the monitor in detail. This course is again programming course, so we focus on the software aspect. The next is the communication device. So a communication device is any device that make it possible for 2 or more computers to communicate, even through the internet also. So we have so many different types of communication devices. Example given here will be the modem. Modem make it possible for us to use the internet. For example, I have my internet, there should be my computer, there should be a modem. When I'm working on my data, My data normally with the computer is in digital. Now, when I want to transfer the data to another computer, maybe it has to pass through a telephone line or analog. So this means a modem will convert the digital signal to analog signal. Then at the receiving end, computer again understand digital. So the modem in the receiving computer will convert the analog back to digital signal. So a modem is a communication device. We also have the NIC. NIC is the network interface card. When we connect two computers or more computers together, we need a network interface card, which is like an adapter to connect the two computers. So here we say a regular modem uses a phone line and can transfer data in a speed up to 56 bits per second. We also have the DSL, which is the digital subscriber line, also uses a phone line and can transfer data in a speed 20 times faster than the regular modem. I quite remember back somewhere late 1990s, most of our internet used the 56 kilobyte per second speed modem. Today, those days, there was no YouTube and there's no much information online. Today, we cannot use 56 kilobyte per second speed for the internet because we have so many huge amount of data. Also, a cable modem uses a TV cable line maintained by the cable company. So a cable modem is as fast as the DSL also. Most computers today, we use the DSL, or even now we are using fiber optic cable, the more faster internet also. The next is now we go to programs, which is the software aspect now. So what is a program? In program normally is an instructions that tells the computer what to do. So here we say computer programs, also known as software, are instructions to the computer. And this is the main goal of this course. We are going to learn how we can write or create a software, a program to do any type of work we want to. A very simple work, we can write a program in Python to find a sum of two numbers or a product of two numbers or to display some message. So again, a program is an instruction that computer will follow. So you tell the computer what to do through programs. Without programs, a computer is an empty machine. So computers do not understand human languages, so you need to use computer languages to communicate with them. Programmers are written using programming languages such as, again, Python, which we are going to learn, and also Java, C++, etc. So a machine language, as we said earlier, is the computer language. That's the language the computer understands. So it's 101010. In the earlier stages of programming, programmers must write the program language in machine language because those days we don't have a compiler or a translator or interpreter to convert the language from either English language to machine language. So those days we have to write the program in machine language. So here we say a machine language is a set of primitive instructions built into every computer. The instructions are in the form of binary code. So you have to enter the binary code for various instructions. Programming with native machine language is a tedious process. So in the earlier stages of programming, to be a programmer or to write even a simple program to find a sum of two numbers, it takes time because again, we have to write everything and we have to write a program that will interact with the computer hardware directly for the computer to understand. Today, we can write a program in Python, which we are going to see an example, maybe only 2 lines, 3 lines to find a sum of two numbers. But again, we have to compile this program so that it will be converted to machine language for the machine to be executed. The next generation was the assembly language. So assembly language were developed to make programming easy. So instead of using machine language, now we can use assembly language. Assembly language also have to have a special program which we call the assembler that can convert the language to machine language. So since the computer cannot understand assembly language, however, a program called assembler is used to convert assembly languages program into machine code. So example is given here. To add two numbers, you might write something like this: add two numbers. Then again, we have to convert this. As we can see here, we have the assembler. This will be called a source file. Then we have the assembler that will convert it to machine code file for the program computer to understand. So next is what is a high-level language. This is where we are now. So Python is a high-level language, C++, Java. Normally, these languages look like English. Example given here. I want to find an area, let's say an area of a circle. The radius is 5. So I may declare variable area, if then I may assign it to 5 times 5 because 5 square times 3.1415 because it's per r square. Pi is 3.1415. So we can see this formula is more or less English. This is a Python language. Then we have to have the Python compiler or interpreter to convert it to machine language. So here we say the high-level language are English-like and easy to learn and also very easy to program. This is why today programming is very easy comparing to 50 years ago somewhere. For example, the following is a high-level language statement that output the area of a circle with the radius 5. Now, these are some of the popular high-level languages. These are the earlier ones, somewhere in the 70s, 80s. We have COBOL, Fortran. Then Java came out somewhere around 1995, mid-1990s. We also have BASIC, Pascal, Adult, C, Visual Basic, etc. Today, most of the common language we have today is the Python, C#, C++, and Java, and maybe Visual Basic also. Microsoft use it a lot, so it's common. Now, when we go to more programming language, computer game, to write more computer code, most likely we will use C++. So everything depends on the business organization or the company, what type of applications they are producing, whether business applications or gaming, etc. AI, for example, data analysis, machine learning programs. Mostly we use Python and most likely Java also. Now, the compiling source code, as we said, this program or this course is again computer programming course. And most of the programs here is written in Python. This is a Python class. So we are going to write all our code in Python language. So when we write our code in Python language, we will call it a source file. Then we need a compiler. So our next lectures, we are going to discuss how we can download the platform, the Python development environment. In this course, we are going to use Anaconda with a Spider. If you prefer to use a Python, I think right now we are in Python 3.7 or 8 version. It's up to you. So when you create your source file, you are going to compile it. Then it will turn to a machine language. Normally, our platforms, for example, the Spider may have the library files. So if you import any library files, there's going to be a link. A linker will link it. Then execution will take place. This is all done automatically. The only thing we need 2 steps. I write my code in source file, I save it, the source file, then I compile it. If there's no error, then I run it, and the computer will do the rest for the rest. Next is what is an operating system. This is a very special operating system. So in general, a software consists of 2 types. We have the application software and we have the system software. System software are normally softwares that interact with the computer hardware, also manages the computer hardware, communicate with the computer hardware. And we have different types of system software. Example would be the operating system, which is the most common one. Every computer must have operating system because operating system software is the software that normally manages all our computer hardware resources, such as the CPU, the memory, the storage device. The operating system communicate with them. And this operating system may come with the device drivers. So for example, if I bought, let's say video camera and I want to attach it to my computer, I may have a special software which we call the device driver or the video driver. This software either is already in the operating system or we have to store it so that the computer can be able to communicate with the printer. I mean, in this case, the video camera. So an operating system, again, here we say it manages and also control the computer's activities, everything. We have a special class, a course in our school, which is an operating system. We go more detail about operating system. Also, operating system is one of the complex software. So again, operating system interacts with the computer hardware, manages everything. Then the application software such as Microsoft Word, the web browsers, etc., computer games, they are all special software that perform a special task. Or we say a software that perform a specific task is called the application programs. So that will be the conclusion of this lecture. Again, these lectures, we haven't started Python yet. In our next lectures, we will start with the Python. This is just to give us some idea of a computer terminologies and some few definitions. So again, wish everybody the best. Thank you.